All right. Go. All right. Well, hello and welcome, everyone. It's wonderful to see all the participants here today. Thank you so much for taking the time to join us this morning. On behalf of Literacy Link South Central and eChannel, I'm pleased to welcome you to today's webinar, Beyond the Algorithm, Addressing Automation Bias in Get Set. My name is Sarah Gover. I'm the director of eChannel at Contact North, and I'll be your host for the session. I'd like to begin with a provincial land acknowledgement. We respectfully acknowledge that Contact North's work and the work of our community partners takes place on traditional Indigenous territories across the province. We are grateful to be able to live and work on these lands. We express our gratitude to the First Nations, Métis, and Inuit peoples who have cared for these territories since time immemorial and who continue to strengthen communities across Ontario. So before we get started, just a few housekeeping notes. We're using Zoom webinar today, so participants' microphones and cameras will remain off. However, as you can see, the chat is open, but do please select everyone in the drop-down menu when posting. If you do have any questions, kindly use the Q&A tool located at the bottom of your screen, and we'll pause a few times during the webinar to address those questions. Live captioning is available. To activate it, simply click the closed caption icon at the bottom of the screen. And after the webinar has concluded, a survey link will pop up on your screen. Please take 1 minute to provide feedback on the session. You will also receive a link to the recording via email in about 24 hours after the session. Okay, well, that's it from me. On to our main event. It's my pleasure to introduce our speaker today, Jeremy Marks, Project Manager and EdTech Researcher at Literacy Link South Central. With over 2 decades of teaching experience across Canada and the US, Jeremy specializes in essential skills education. His fascination with AI stems from a deep passion from educational theory and cognitive philosophy, exploring how technology can transform the learning experience. Thank you, Jeremy, and great to have you join us today. I just wanted to say also thank you to Roman for our ASL interpretations. So over to you, Jeremy.
Thank you very much. Well, it's great to be here again. I always enjoy having the opportunity to do these AI Bytes webinars. We've been doing this now for a couple of years, and it's been really fascinating, for me at least, to see how these discussions have evolved, as well as how the topics have evolved. And for those of you who haven't had a chance to take a look at the latest issue of AI Bytes number 10, one of the things that my colleague Carolina Cahoon and I focus on is the subject of automation bias, which I'll get into in a little more detail, obviously, in a couple of minutes. But it's one just sort of preamble, I guess, is that it's really interesting to be at this point where we're having this conversation about automation bias, because I recall when we started the AI Bytes newsletters, a lot of the people that we were working with, myself included, were very, very new to AI. And we're really just trying to get our heads around, what is this tool? How can we use it? How is it going to make, not even in terms of how is it going to change the way that we do our jobs, really, how do we just begin to take those first steps in introducing it into our daily instructional practice, into our planning, et cetera. And here we are a couple of years later, and now we're talking about something called automation bias, which I find to be a fascinating topic in and of itself. And I hope as we go through this that you'll find some of the questions that I raise for you to be thought-provoking and engaging. So let me share my screen here, and I'll get us launched into the slideshow. So if you have had the opportunity to see this, the latest edition of AI Bytes, one of the things that you will know is that Carolina and I made a bunch of references to the world of science fiction, specifically the film, as well as the novel 2001: A Space Odyssey. So for those who are not familiar with 2001, I apologize. Some of the slides you're going to see are direct references to that film, but my hope is that I'll be able to weave in a little bit about that film and why it's relevant to this conversation about addressing automation bias. Okay, so automation bias, really in its simple terms, can be defined like this: machine yes, human no. In other words, there is a view, not universally held, but that machines are more trustworthy than human beings. And there are a number of reasons why people have that view. Like I said, it's not a universal view, but there is this underlying idea that if we want the right answer, we should go to the machine first. And so one of the things that makes the 2001 film, I think, a really interesting cultural reference point for this discussion is that if you have seen the film, and this is not a spoiler alert, one of the things that you know about it is that these astronauts, who you can see on my slide deck, are on this voyage to Jupiter, and their ship, the Discovery, is in the hands of a super intelligent computer, the HAL 9000. And the HAL 9000 automates the vast majority of the systems that are run on board the Discovery spacecraft. The scientists, astronauts, are there to do experiments. They're there to make observations, but a significant portion of the functions of the ship have been turned over to this highly intelligent computer. And one of the things that we're also told at the very beginning of the HAL 9000 segment of the film is that the 9000 model never makes mistakes. You hear that right away, that it is flawless, that there is no record of it ever making an error. Well, even if you haven't seen the film, I think you can probably guess where some of the drama in the film comes from. It comes from the fact that, in fact, the HAL 9000 does make errors. And not only does it make errors, but these are critical errors. And then on top of that, you have these very interesting conversations that take place between the astronauts about, okay, well, they start to suspect that the machine is wrong. But because their entire ship is driven by this machine, and because so much of their mission is floated by or built on the removal of all different kinds of daily tasks and forms of problem solving, what are they going to do if, in fact, the computer is wrong? And so the slide that you're looking at here is actually a very famous scene in the film where the two astronauts, Frank Poole on the left and Dave Bowman on the right, want to have a conversation about their concerns about HAL's functioning capacity. And they're doing it inside a pod where they don't think that HAL can hear them. So what they've done is they've gone in the pod and they've turned off the audio, so they think they can have a conversation without the computer noticing. But one of the things you might be able to see in this slide is that smack in the middle, that little red circle is HAL, and he's watching. And not only is he watching, he can read lips. So in they have their bias is toward the assumption that if the machine can't hear them, it doesn't know what they're saying. But of course, that is an auditory bias that they indulge in. Okay, so I want to get into a discussion about why it is that there is a tendency in the world of automation bias to trust the machine more. So there are five, really six things that I've put up on the screen here that I think are relevant to why it is that people are often inclined to put their faith in the machine. Some of these are things like, and I think sci-fi is a really good connection here, that we are dazzled by lightning fast computations, that we're dazzled by the things that a computer can do or a machine can do remarkably quickly. That also connected to that, the machine itself appears as what I like to call a black box of wonder, that things happen inside of it. We don't really know what those things are or how they work. But what we do know is you put something in one end of the black box, you get something out at the other end, and magic happens. Now, computer scientists will tell you it's not exactly magic, but I think you get the idea that something truly remarkable happens. And if you've been around long enough to watch the evolution of computers, you can still be amazed by this because, for example, I still recall the first time I ever encountered the internet as a kid. It was actually in the 1980s, and it was because my father had access to a government website and a government information network. So I actually had the opportunity to see a very, very early form of email, again, back in the 1980s. And I was amazed. I still remember trying to get my mind around the idea that something that he was typing onto a screen could be sent overseas and reach a friend and colleague of his in a matter of minutes. That was a moment of true wonder for me. So there's your black box. Then, of course, connected to that is that computers and science, technology, engineering, and math, or STEM, are held in very high esteem, not just in the world of business, but more broadly now in the culture. That there is an association with STEM and people being absolutely on the cutting edge. that people who understand math and science are able to do things and solve problems in a way that people who don't have those skills cannot. And then, of course, directly connected to STEM is the idea that if you have these skills, you can build machines. And those machines can do wonderful and wondrous things. Then, of course, also there's the question of how machines and automation saves time. I mean, that's as old as machines themselves, right? Why do we build machines? Because we want to save time, because we want to free ourselves to do other tasks. And then, of course, at the bottom, you can see directly connected to that, time and productivity have become prized commodities. That time and what we can do with it and how much we can produce within that period of time can make a difference between profit and loss, certainly enters into performance reviews and evaluations. And so, connected to that, computers and AI have, I think, already been mythologized, not just because we don't necessarily, many of us, fully understand how they function, but also because they do remarkable things. And as a result of that, we can perhaps accomplish things at a level of speed and maybe a level of depth that we couldn't accomplish before. So I want to sit with this for a second. I've prepared a poll, and I'd like to actually get your feedback and vote on this. So Sarah, if you wouldn't mind posting that first poll, I'd like you to choose one of the following options. So my question for you is, why do we trust machines more than people? If you could pick one of those options and share it with the poll, I'd be very curious to see the group's response. I always enjoy watching polls as they collect their data in real time. I always find that fascinating. It's interesting too to see how many of the results up here are spread out. And so it's not, everybody is not giving just one answer, which I think is also really interesting. Okay, we've had everybody participate, which is great. So if we can go ahead, Sarah, if you wouldn't mind sharing the results with all of us, that would be great. All right, so it appears that computers and STEM are held in the highest esteem in our national culture. And so of the 13 people who voted, 6 of the 13, so nearly half, said that we trust machines more than people because of how they are held, the esteem in which or with which they are held by the national culture. I think that's a really interesting response. We also had 3 people who said that machines are devoid of emotion, which is one of the reasons why we tend to trust them. 2 people said the computer and its capabilities have been mythologized, and 2 people also said because machines are faster than people. Okay, excellent. All right, so there we go. The flip side of this, of course, is why do we trust human beings less than we do machines? And on the one hand, you could argue that this is an obvious, that it's obvious that if we trust machines more because, let's say, they're less emotional, then we could turn around and say, well, we trust machines more because they're less emotional. We trust humans being less because they're more emotional. But I don't know that it's that simple. And I like the fact that a number of people really honed in on the idea that the way in which we talk about machines, the way we talk about computers and AI within our broader culture really does lend not only to the mythologizing of technology, but also to this broader, let's call it a broader assumption or a broader understanding that we just should put our trust in machines. So 4 possible reasons that I've put here about why we trust human beings less is that human beings are mistake prone, though I should emphasize, I think as we all know, so are machines, that people are slower to solve problems, that human beings are on a journey from confusion to clarity. And I particularly like that one because that was something that Carolina wrote in this current edition of AI Bytes, that one of the things that we have to keep in mind is that Machines aren't on that journey from confusion to clarity. They're not thinking through or trying to grasp things in the way that the human mind does. And so it's worth sitting with that for a moment about how if human beings start from a place of not knowing or even confusion, is that a problem? Does that have to be a problem? And then finally, computer memory seems like it's infinite. Human cognition appears finite. And the only way for the moment, that I'll qualify that last statement is that if you talk to programmers, they will tell you that computer memory is not infinite, that they are trying to explore ways to expand it through quantum computing, that human cognition also appears like it's finite. But yet, on the other hand, one of the things we know about human history and the human technological relationship is that human beings are always finding new ways to develop tools and to think about things. So I guess part of the interesting aspect of this discussion is how comfortable are we with the idea, or do we believe that the computer can just continue to grow and expand and compute, but that human frailty, human fallibility is a barrier? So by that, I'd like to introduce my second poll. So Sarah, if you wouldn't mind posting that one, I want to explore the question of why we trust human beings less than machines. Here we go. Okay, so my next question for you is, which of these assumptions about human beings seems the most correct? And as you can see in front of you, there are 4 options. Human beings are mistake prone. Humans are slower problem solvers than machines. Human beings are on a journey from confusion to clarity. And again, computer memory appears infinite, while human cognition seems finite. Okay, so everybody has participated now, and the winner here, so to speak, is the 4th option, that computer memory appears infinite while human cognition seems finite. Okay. I can honestly say that when I came up with this poll, I didn't have any pre-existing assumption about how people were going to respond, because just speaking only for myself, I find all 4 of these reasons to be plausible. So it's interesting to me that almost half of the group chose the computer memory appearing infinite and human cognition seeming finite. All right, so I recognize the fact that we don't have, that participants do not have a microphone option, but I'm interested if anyone would like to put an answer into the chat about why you chose the 4th option, about why you selected computer memory seeming infinite and human cognition finite as your reason for why humans tend to trust machines more than they do their fellow human beings. And I'll pause for a moment while we wait see if anyone has a response. One of the things that I often think about with this, and I've had this conversation with students of mine, is that some of it has to do with the fact that now we can outsource a lot of information to the internet that we don't have to carry around in our heads. And I see a couple of people have already actually spoken to this directly. So Mary writes, the computers draw from all the knowledge available on the internet. Patrick writes, the computers are quick to spit out info, while humans can be like, it's on the tip of my tongue, I can't think of an answer. Absolutely. So yes, quickness, absolutely. So these kinds of things, the convenience aspect of things, I think certainly plays a role. I know, again, in talking to students, that one of the things that people are often really drawn to is that if we're having a conversation about something, and I'll use Patrick's example, someone says, well, it's on the tip of my tongue. immediately 5 people will pull out their phones and go and find the answer. And so there's this idea that, well, if the human mind is, if someone's memory is limited, or if they're having a moment, a brain freeze or something, people know, okay, well, great. I don't have to worry. I don't even have to necessarily wait for a response. I can go directly to the source. I can go, and I emphasize that I can go to the source, because part of the assumption too in automation bias is the source. The source is machine. The source is computer. The source is not human. And what I would argue, and I feel this is particularly relevant to get set, is that while computers draw from all the knowledge available on the internet, which is absolutely right, who put it there? Where does that knowledge come from? And so I feel like this is an element of automation bias that deserves further consideration, is that yes, machines have these capacities, but what about the human role in the design, development, and programming of the machines, as well as we have this enormous beast that is the internet that we created as human beings, that we contribute to as human beings. So what role does that have? Okay. So that connects to my question about moving from confusion to clarity. What is wrong with not knowing something? And I want to emphasize this for a moment in terms of teaching, in terms of instruction, particularly in Get Set. I've had many conversations with Get Set instructors. I have been a Get Set, I should say, a Get Set instructor myself. And there are definitely times where I do not have the answer to a question that is asked of me. Or I will say, let's say it's something pertaining to math, I will say to a learner, I have to go back and look that up. I have to go back and revise or review the way in which I understand that concept, because it has been some time, not only since I've done it, but also since I've had to explain it to somebody else. And I feel that in those moments, you could call that confusion if you like. But on the other hand, it's also an opportunity to think, engage, problem solve, talk. But it's also an opportunity for something else, which I'm going to come back to toward the end of my presentation, which has to do with narrative, which has to do with storytelling. If I don't remember how to teach something, or if I don't remember a certain concept, if I have a good relationship with the learner, one of the things I can talk to them about is the last time I did this, why it is I might not have practiced this particular mathematical concept in a long time. I can have a conversation with that learner about my relationship with math. And I feel that that narrative component, that conversational component, is something that actually is immensely important, especially when we're confronting automation bias. Okay, so if you've had an opportunity to take a look at the latest issue of AI Bytes, one of the technologists that is quoted is a man by the name of John Nosta. And Nosta is somebody who runs a organization called the Nosta Lab. He's done a lot of articles for Psychology Today. His background has to do with health literacy, digital health. And he's written some interesting things about the relationship from not only a cognitive point of view, but an educational point of view of the learner, the human being, and the machine. And so one of the things that he likes to emphasize is that human thought has always relied on friction as a form of cognitive resistance. That, in other words, when I try to learn something new, or when I teach something, there is a resistance that can take place. Sometimes that resistance can be, I don't like what I'm learning. I don't like the way the information is being presented. Sometimes it can be an idea or a concept that challenges me, maybe on an emotional level, maybe on my worldview. It gives me an idea or information or a perspective that I dislike. Part of the beauty of teaching, part of the beauty of education, is to work with that resistance, that friction. And so Nasta emphasizes the fact that those interactions that are fractious, where friction is front and center, are extremely valuable, because they also are a part of this move from confusion to clarity. They are a part of the learner as well as the educator's process of taking in new information, not just because that information might be logical, not just because it might be efficient or numeric, which a machine is looking for, because AI in particular looks for patterns. The human mind looks for patterns, but the human mind and the human being are also reacting to information on an emotional level. They are reacting to information on an environmental level, which is one of the reasons why we know that with the principles of adult education, it's so crucial to create certain kinds of learning environments where, for example, people not only feel physically comfortable, they also feel free to question and to resist and to challenge. But that at the heart of all of that is narrative. And so Nasta also makes the point, as you can see, it's the second item on here, that large language models, part of AI, possess sequence without narrative. That in other words, information is presented sequentially or as logical, but it's often, as I think everybody here knows, decontextualized. So we don't necessarily know what this information pertains to, what it's related to. So if we're talking about AI with students, for example, there can be certain bits of information that I know about AI, but there may be aspects related to programming, related to different types of computation or computing that I might have read something about, or I could rattle off a couple of facts, but I don't necessarily have the narrative to explain not only what this particular computational principle is, but also how it developed. Because one of the things that we also have to take into consideration in education is not just the principles and the ideas, but where they come from, how they were developed. And certainly, if you have a background in humanities education, you know that in humanities education, there is a lot of disagreement or contestation about sources of knowledge, sources of information. So cognitive resistance can also be about getting right to the root of, how do I trust a source? How do I parse the information that I am getting? How do I go about doing that? And so, as you can see, Nasta emphasizes that we need to test what we are learning. We also need to consider it how it becomes a part of our personal narratives. And one very specific example of personal narrative that I will use is the amount of times I have had people to say to me, I can't do math. I am not a math person. That is narrative. And so when somebody tells me that they can't do math or they're not a math person, what I'm interested to know is, okay, how did they get here? What has led them to believe that? AI can't tell you that. AI is not interested in or not designed to get into questions of that nature. So as educators, when we think about automation bias, we are confronted with questions all the time, or observations or confessions by learners, admissions, that very much are about narrative. And therefore, our judgment and the use of our judgment as educators is crucial. All right, so I want to take a step back for a moment here and talk to you about something that comes up in the AI Bytes newsletter, and that is called the Goldilocks effect. I imagine everybody has heard the Goldilocks story. At the heart of Goldilocks is the idea that she's looking for something that's just right, whether it's porridge, whether it's a comfortable bed, whether it's a comfortable chair. Goldilocks will try porridge that's too hot or too cold, and then she'll find something that's just right. And when we read this story or have this story read to us as kids, we're never really sure what it means exactly that something is just right. I mean, if Goldilocks finds the bed just right, will I also find the bed just right? If it's comfortable for her, will it be comfortable for me? Same thing with the temperature of the porridge that she eats. But that, I think, is an interesting metaphor, because the Goldilocks effect is about how we as human beings have a tendency to absorb and assimilate information that we think is just right. It feels right. And when we ask the question, how or why does it feel right, that can take us in many different directions. We can talk about how it seems logical, it makes sense. But if we're asked to prove why it's logical, or how and why it makes sense, then things start to get to be a bit more complicated. And again, this is where narrative can enter into the story. So here's a lengthier definition of the Goldilocks effect, which I take this directly from AI Bytes. It's our inherent tendency to crave information that seems or feels just right. that isn't too long or complex, but it's also not too simple or watered down. That we're looking for something that sounds intelligent, articulate, that appears to have explanatory power, but is also, I'll call it digestible, that it's something that we are able to use, that it's something that we can grasp. Now, I'm not saying that everybody all the time is a victim of the Goldilocks effect or goes about collecting and assimilating information in this way. But I think that, and again, I think this relates to the automation bias, with AI, with computational capacity, computers are designed to just give you answers to any kind of question that you have. It could be about any topic, any subject. And so that's part of the wonder or the wow of computers, is that you can throw all these different, call them Jeopardy questions, at a machine. One minute you're asking about, American football. The next minute you're asking about, winter weather patterns, freeze and thaw effects on the Great Lakes. You get the idea. You could just go on and on with this. And the computer doesn't say, well, wait a minute, that's on the tip of my tongue. It generates answers. And so when you think about that in a human context, the Goldilocks effect can be about things that we're less confident in. We may feel really confident about our knowledge, for example, of certain kinds of math, but we might feel less confident in our knowledge about how to teach certain, let's say, humanities concepts, because we're less certain about how to communicate those in a way that is culturally sensitive. And so if we're entering into a new field or a new area, we might want things that feel just right. Strategies, concepts, ways of conveying information that fits in nicely, kind of like a puzzle piece with the existing puzzle that we are building. And so I don't think that the Goldilocks effect in and of itself is this nefarious, terrible thing. It's something to be aware of, that we can be conscious of. And again, a question that I will ask and kind of let linger here is that, could we argue that automation bias itself is actually a form of the Goldilocks effect? That if we give machines more credit than they necessarily deserve, is that part of the Goldilocks effect? That's a question I've been thinking about quite a bit, and I have many different responses to that, but I don't have a single answer. Okay, so what I'd like to do here for a moment is I want to create a scenario for you that I think brings the Goldilocks effect into play. Imagine that a learner comes to you and asks very broadly, what is AI? They want a good working explanation of AI. So you research the question and you find some different definitions of AI. I've done this for you. I've got 3 that I'm going to show you. And so the question is, which one of these definitions would you use to answer their question? And then also, depending on the definition you choose, ask yourself, why did I choose it? So I'm going to show you those 3 definitions now. Again, imagine a learner comes to you and says, can you tell me what AI is? Can you explain it to me? And so here are 3 definitions. I'm curious to see which you would choose. Here's definition 1. AI is the theory and development of computer systems capable of performing tasks that historically required human intelligence, such as recognizing speed, making decisions, and identifying patterns. AI is an umbrella term that encompasses a wide variety of technologies, including machine learning, deep learning, and natural language processing. So I'm just going to leave this here for just a second so you can absorb that definition. And then I will move on to definition 2, which, as you can see, is longer and more detailed and also in point form. Okay, definition 2, any artificial system that performs tasks under varying and unpredictable circumstances without significant human oversight, or that can learn from experience and improve performance when exposed to data sets. An artificial system developed in computer software, physical hardware, or other, it should be contexts, that solves tasks requiring human-like perception, cognition, planning, learning, communication, or physical action. An artificial system designed to think or act like a human, including cognitive architectures and neural networks. a set of techniques including machine learning that is designed to approximate a cognitive task, an artificial system designed to act rationally, including an intelligent software agent or embodied robot that achieves goals using perception, planning, reasoning, learning, communicating, decision-making, and acting. And you will notice at the bottom of my slide here, this definition comes from NASA, the American Space Administration. And then finally, definition 3, artificial intelligence, AI, is the simulation of human intelligence processes by machines, especially computer systems. It includes learning, reasoning, and self-correction. Examples of AI applications include expert systems, natural language processing, speech recognition, machine vision, and generative tools like ChatGPT and Perplexity. So I'm going to ask you for a gut reaction or an instinctual reaction to these 3 definitions. Which one would you choose? And I'm going to move it to the next slide, but I'm going to pause here for a second. So if you wouldn't mind putting in the chat, just you could put a little description of what you chose, or you could just put a number. You could say 1, 2, or 3, and let us know what you chose. Okay. So far we have a 2 and we have a 3. We have a bunch of 2s. Very cool. So a bunch of people went for the longest definition or set of definitions. Very interesting. Yeah, okay. So far, overwhelmingly, people are picking the second slide. Would anybody like to put into the chat just a very brief sentence or 2 about why they chose the second option, the more detailed one from NASA? So Kathy wrote, it looks really comprehensive. Yes, I agree. And then Bruce put, AI is computer technology that helps machines. Actually, a whole bunch of them are coming in through very quickly here. Awesome. All right, so I'm going to go back to what Bruce had put. He said, sorry, bear with me a second as I work this. AI is computer technology that helps machines to do things that usually need human thinking. This includes understanding words, answering questions, recognizing pictures, making simple decisions. Yes, that's great. Patrick put more straightforward, less jargony for why he chose the one he did. Angela put for number 3, connects more with my own knowledge about AI, is also the one I feel most able to answer for follow-up questions. Also, I feel like I'd lose a learner with the other 2. Interesting. That's a really thoughtful answer, Angela. I was thinking something similar to that actually when I was looking at those 3. And then Bruce also put about how the importance of plain language that learners can understand. Yes, these are great answers that you provided, because I went back and forth with this as well. I thought about how the second slide struck me as being the most comprehensive, certainly. And I can't deny the fact that that there's that because it's from NASA, that maybe you could call it a bit of my STEM bias kicked in. I thought, okay, I'm very aware of what NASA has accomplished over the course of its organizational history. But at the same time, too, I like the fact that people are responding to these from a variety of different perspectives. What will the learner think? How capable am I of answering follow-up questions? Which of these definitions am I most able to explain? Or also, too, I liked another comment that went up about how only a true scientist would like the first definition, which I thought is great as well. You can look at these definitions from all of the perspectives that you've just mentioned, and I would argue that what you're illustrating actually, once again, not only has to do with your own judgment as educators, but also this question, once again, of narrative. In other words, how well do I know this learner? Which set of information, which set of details are going to be the most compelling to them? Which are going to be the definitions or approaches that they're most likely to engage with or best understand? Which are the ones that I'm best able to explain? What do I feel most comfortable with? And then I also think about the fact, too, that what's interesting about this is that these kinds of questions or these kinds of definitions invite questions, invite a further discussion. I think about the fact that if somebody were to ask me what AI is, one of the ways that I might approach that is say, here's what I think, but here's what I'm not sure about. Or if somebody says to me, where do you think, and I hear this question a lot, where do you think AI is going? Where are we going with this? How is this going to change our lives? Am I going to be able to find a job? I hear that. And I have to be very honest at moments like that and really start from a place of here's what I think I know, and here's what I don't know. Here are the limits of my understanding. And I feel like those kinds of conversations, especially when they come from a place of confusion or not knowing, maybe you don't like the word confusion, maybe you could just put it as a place of not knowing, is critical here because learners as well as instructors deserve to be uncertain. They deserve to have the opportunity and the privilege of being uncertain. And of course, with that uncertainty comes other questions, which I talked about in a previous webinar we did about how do we exercise our critical thinking. When we're talking about automation bias, we also, I think, have lingering in the background this question of critical thinking. How am I able to not only examine my own assumptions and examine the limits or the growth in my own understanding, but also, once again, especially when dealing with automation bias, how do I know that I can trust the information that the machine or AI is giving me? Because as everyone here knows, AI is often mistaken. It often hallucinates. It often gives information that is incorrect. And for us to know or be able to identify that it is incorrect, we have to have not only an existing knowledge, we have to have a trust in ourselves that we have the critical thinking capabilities to challenge what we're seeing. And then also, too, in an instructional environment, those types of questions, challenges, and even the friction that I was talking about earlier, that those are encouraged. Okay, so I want to pivot to the case for human instinct here. And so again, as you can see from the slide, this is a direct reference to the movie 2001. And again, I'm going to kind of get a little close to a spoiler alert, but I'll try not to go too far. One of the things that happens in the course of this movie is that one of the astronauts realizes that because they have this problem with the HAL 9000, they've got to go in and they've got to, let's say, limit the computer's functions. So the slide that you're seeing in front of you is when Commander Dave Bowman goes into basically the mainframe of the computer and starts to tinker with HAL 9000's programming, because there are certain things that he thinks the computer can do, and there are other things that he doesn't any longer want it to do. And he has to trust his instinct here, because where the HAL 9000 system is concerned, as I mentioned earlier, there's never been computer error before. So what happens when you're the human, the one who's supposed to be the inferior intellect, recognizes and identifies a problem and then has to take action? Well, if you're entering a realm unknown, and Dave Bowman is literally doing this, not just with HAL, but also his ship is en route to Jupiter, where no human beings have gone before. This is the case for human instinct. So I like to think about this, obviously, in terms of our role as instructors. What is it that the human instructor has that the machine does not? And I know that there are people who are deeply immersed in AI who might challenge me and say, well, the machine might not have this yet. And that question of if it'll happen, when it will happen, is a topic unto itself, as I'm sure you can imagine. But the case I want to make here is that the human instructor is physically, cognitively, and emotionally present. The computer is not. The computer is certainly physically present, but it is not emotionally available. And its cognitive presence is subject to debate, which I recommend reading a bit of AI Bytes, where Carolina gets into some detail about that, about the difference between computer cognition and human cognition. The human instructor can move with the learner from confusion to clarity. One of the things I personally appreciate most about teaching is that move from confusion to clarity is often mutual. I can't tell you the amount of times, just in my own experience or with instructors with whom I've worked, who have said, I didn't really understand that concept fully until I was required to actually teach it. And so there's this fascinating situation that arises where there can be this question of who taught whom exactly, because the learning is joint. So the human instructor can move with the learner and themselves from confusion to clarity. They can, and so often do, utilize instinct and experience. They can communicate non-verbally, and they can also understand, or the human instructor understands the learner's story. So I recognize that the things that I am mentioning here are, for anybody who has been involved in education for any period of time, you can say that these are very common sense and probably pretty obvious observations. What I would say about that, though, is that it is interesting how quickly these facts are discarded because of the broader emphasis upon productivity, the broader emphasis on speed, efficiency, and so forth, about how human interactions are not always efficient. They are not always, they don't always meet a clock. They don't always follow a predetermined mathematical schedule. And therefore, as instructors and as adult educators who also are in the situation, of course, of working with people who, unlike kids who are supposed to be by law in a building for a certain number of hours a day, a certain number of days a week, the adult learner is not like that, as everyone knows. They come and they go based on a wide variety of factors in their lives. And so I think it's safe to say that because the adult learner, especially in the get set world, is there fully by choice, or most likely fully by choice, the nature of the human interaction, the nature of the instructor learner relationship is actually quite different and really does not lend itself to super time efficient schedules. The provincial government may disagree with me on that, and I'm certainly prepared for that. But I would argue that the relational nature of education, especially in adult education, is critical. So how does this, again, pertain to automation bias? Well, to use but one example, if you have learners who are returning to the educational world for the first time in a very long time and have had experiences in the past that have been negative or have been disrupted by the infinite number of life circumstances that cause disruptions in learning, trust is really the foundational principle of making that learning process happen and continue. And I would say that when it comes to computers specifically, because I have witnessed this, computers, there is an assumption in certain educational circles where everything begins and ends with the computer because of all its many functions, because of its, again, speed, efficiency, because of the fact that it is this incredible tool for accessing data. But as I imagine many of you have experienced, there are people still who are intimidated by digital technology. And it isn't just because they might not have grown up with it, because we certainly see that, the famous digital divide between those who have grown up with handheld technology and computers and those who have not. But there's more going on there than that. There's also the question of social trust. And so one of the things that often comes up, at least in my experience working with learners and talking to educators, is that there is a lot of suspicion and fear of technology. And it's not just the idea that, well, if I didn't grow up with a phone or a personal computer, I can't do it, or I'll never be able to master that technology. It goes much deeper than that into broader social issues, political issues that are certainly having a direct impact on our societies right now. I don't have to list those. I think people could probably come up with 5 right off the top of their heads. But the omnipresence of computers, the fears associated with automation, of AI, the issues of surveillance, these things are having a significant impact on the way many people interact with computer technology. And so again, I would argue that this is where we have to pay particularly close attention, not just to relationships, but also this element of personal history and narrative. And I think, as well as educators, as instructors, to really look at in ourselves how we use AI technology. What things do we expect it to do for us? What things do we trust it to do for us? And I would even go a step further and say, if you're thinking about using it as a brainstorming tool, for example, to help learners, to work with learners, to tackle ways of teaching new material, or trying to teach learners who, let's say, have specific types of learning disabilities, and you're trying to brainstorm and figure out, what are the best strategies for that, and you want to use AI. It's reasonable to ask, how much of this am I willing to trust to the software, to the machine, to the program? But at what point do I need to make sure that the learner comes first, that I ask them, or that I am able to ask them for their advice or their input in terms to helping them go about learning something? How much conversation am I having with other instructors? How many conversations am I having with people who might have expertise in certain fields of psychology, of education, of learning disabilities, of dyslexia, etc.? How much of this do we think or do we assume can be handled by an automated system? How much research and understanding do we feel we can set aside because an automated system can give us bits and pieces of information that seem plausible, that we can understand? Here's your Goldilocks effect again. And that because we face time and efficiency pressures, we feel we can move with really quickly. And so I think that, to return to the theme from the very beginning about the tension between automation bias and human trust, really does come back to this question of, also, what do our environments allow us to do in terms of how we think about problems like these, like automation bias? How comfortable are we to be able to involve learners, to put them first and foremost and not a machine? And I don't say that as a platitude. I mean it as, can we approach a learner or learners from a point of vulnerability or even ignorance and say, I recognize that I have these tools at my disposal, especially AI, that might enable me to come up in 20 seconds with 20 ideas about how you and I can go about studying a concept. But let's take a step back here and say, where would you start? Or, I'm going to bring you these ideas, and I want you to tell me which one here you think is actually relevant. How many of these would you just dismiss out of hand? And so I find that component about really looking closely at the nature, not just of the relationships that we are building and that we are expected to have, but also to really double down on, when we think about what learning is and how it happens, how much of that really comes back to instinct and personal narrative. And I'm not downplaying expertise. I'm not downplaying, empirical fact. I am really trying to get back to this basic question of, if we understand that there is such a thing as automation bias, and we understand that there are social and economic factors involved, educational and institutional factors pushing automation bias, how do we handle that? How do we grapple with that? So one of the things that I'm moving toward, as we move toward the end of the webinar, that I want to, again, focus on a little bit more is the importance of personal narrative. And so I've divided the idea of the personal narrative, both in terms of the learner and in terms of the instructor, into two categories. One is metacognition, or, do we understand how we think? Do we understand, the thinking behind our thinking? And then also self-awareness. So I've put under both of these categories two questions. For metacognition, the questions I have are, how do I think? And also, can I tell my story? So if metacognition is about thinking, I think that one of the things that comes from that is, can I tell my own story as an instructor or as a learner? Or can I, in the case of AI, tell a story about something like AI or automation bias? And if I can't, or if I think that I can't, why not? Can I use that problem or that challenge to enable me, whether in myself or with a learner, to double back and find that point of conflict or uncertainty from a cognitive point of view? So if we think about helping a learner understand how they think? Can we find those nodes or those places or junctions where something is tied up or blocked? That's metacognition. And then with that, we can find out, okay, how did that happen? Or why does there seem to be this particular block? Do we know why it's there? Do we know why it's there in terms of your own story or your own personal history? And then on the other hand, there's the self-awareness piece. Why do I think? Why am I having the thoughts that I am having? Why do I have the approach that I have? And I think this can draw on things that are, of course, of a more emotional nature. And then connected to that is, how do I tell my story? Not just putting the facts and the information in the proper order, but what's the tone? What is the voice that I want to use, that I feel is mine? Again, as a learner or as an instructor, the how isn't just the strategies, it's also the voice, it's also the presence, it's also the awareness that we bring and the learner brings to that intersection, that interaction that occurs in education. AI can't handle that yet. AI is not part of that conversation. It remains a tool and a device that you can bring into those interactions, but it does not get into that kind of fundamental educational and human interaction that is occurring, I would argue, in a get set environment. So what I want to close with, as I am mindful of the time, whoops, sorry, I jumped ahead, is a quote that I quite like that I found from an educator who teaches at DePauw University in Indiana, a guy by the name of Derek R. Ford. And he said, if education could be guaranteed, it would be transmission, and it wouldn't involve human subjectivity. Education must remain unpredictable and open. And I love this quote for a lot of reasons, but I thought that I would pair it with a scene, once again, from the movie 2001, where at the beginning of the film, we are treated to about 15 minutes of watching our earliest ancestors figure out how to use tools and how to move from being basically at the mercy of the natural world to figuring out our place in it. And so if you know this story, one night, this large inscrutable rectangle called a monolith just shows up. And in the morning at dawn, when our prehistoric ancestors wake up and see it, immediately they're terrified. They think it's a threat. They think it's dangerous. They're worried it's going to harm them. But you watch this sequence where they approach it and then they back away from it and approach it. And when they realize that it doesn't appear to be harmful, they touch it, they sit beside it, they study it. And then a couple of minutes later, we see an ape figure out how to use tools for the first time, and how when they realize that a simple bone can be a hammer, can be a club, can be a device for making things, destroying things, hunting, it changes the course of human history. Now, granted, this is, of course, a dramatization for sci-fi purposes, but I think about the fact that discovery, uncertainty, friction, and confusion have to take place in order for insight to occur. We have to experiment, we have to try and make mistakes in order for things to actually move forward. So I will stop there. So thank you very, very much for attending today. I really enjoyed having this opportunity to present my talk to you. And thank you for your participation in the chat, as well as with the polls too. And I will put my email in the chat. So if you would like to continue the conversation, if you have any questions for me, please feel free to reach out. I am always happy to respond. And thank you for the kind words in the chat as well. I certainly appreciate them.
Excellent. Thank you very much, Jeremy, for an always engaging and thought-provoking session. Big thank you to all of our participants for attending and engaging with your interactions in the chat. Please remember to complete the short survey after the session, and keep an eye out for the recording link that will be sent to your inbox. Have a great day, everybody.
Take care. Thank you very much.